Welcome to the AI for You Cafe for live presentations around AI. Like always, we start slowly so all the people can participate and come in the cafe. So I will now show you whom we are presenting today. It is Damian Swittering. Hi, Damian.
Hello, everybody. Welcome.
So, and we are today having the title Solving for COVID. My name is Carmen McWilliams, and I'm the moderator and organizer. I'm the director of the company Grassroots Arts and partner in the European AI for You project. Like always, the rules are, please know that in this cafe, the speaker don't share any confidential information, and the speaker can express their personal opinion. This is not necessarily the official AI for You opinion, and the session will be recorded. What is this AI for You Cafe about? The cafe is an online forum to gain insight into the European AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders from various areas of AI research and application. So welcome everybody again. This is great that you all join. Welcome to all the participants. And please know this is interactive. So if you have questions after the presentation, then please write your questions into the chat on the right side. This is like where the control panel is. And I will read them to Damian afterwards. And I'm hoping that you can see the chat. Okay, it's on the right. You see that you do it. Great. And now to Damian. Great that you're here. Thank you. Thank you very much. And your introduction comes now. Damian is an IBM specialist dedicated to achieving real-world results, innovating with information. He was a developer, consultant, architect, and sales engineer in the area of data warehousing, business intelligence, and advanced analytics before his current position as a developer advocate for data science, specializing in the practical application of machine learning and artificial intelligence. Great that you're here. And I think now it's time that you introduce yourself. I will now change the moderator role to you. And then you can say and do what you like.
Yeah, thank you very much for the introduction, Carmen. Yeah, that sounded like a lot of text that you just heard. But yeah, be aware that I've been basically, if you look at it seriously, I've been a data scientist for the past 25 years. So even before the term was actually used. Yeah, and I found out that the stuff that I've been doing for these years, not in the beginning, but for certain in the later years, a lot of people now call that AI. So I'm still getting used to the term. So I still think I'm mostly messing around with data lots of the time. But yeah, I see that it's getting called AI a lot of times. So I'm a bit skeptical about what is AI and what is not. And I guess we will see some of that in the coming 30-45 minutes. But yeah, that's an opinion, and that's just from somebody who's been working in the field for a long time. And we've always been saying to each other, colleagues and me, that probably what we called AI a couple of years ago is now called machine learning, and now the new stuff is called AI. So the term shifts as well. So that's always a discussion that we can have in another session, because we can spend another hour on that. But basically, yeah, I'm from the data mining side, which it was originally called, and yeah, I'm now doing lots of stuff that people call AI. So let's keep it at that. So yeah, what's it about today? Actually, my current role after all these years, after doing lots of projects and also on a bit more on the commercial side of things. I'm now a developer advocate, and that means that I try to inspire developers, and developers in my case are data scientists mostly. I try to inspire them to work with the new technology that is available, and to really look at their data, look at their organization, and look at their their needs in a way that that uses all that new technology and can shed new light on that and give them new insights. So I do lots of workshops. So this is one of many workshops. They are usually for very technical audience, so I really tell them how it works, and I show them how it works and try to inspire them to use it for themselves. So today I will do a little bit more of an overview and a little bit more high level. So if it gets too technical, please tell me. Then I'll switch to the more helicopter view. But yeah, if you're interested, we can do a little bit of deep dive at some places. But yeah, well, then it's only an hour, so we can't spend too much time on that. Yeah, so everything you see today is live. It's available. These last 2 years I exclusively use open source technology. So that was a learning curve for me as well. I used to work with the commercial products of IBM and switched to open source to really see that as an inroad into the into this way of using data and using it to gather insights for your organization. So everything you see today is available. We can share the link even with you if you want to run the code for yourself, if you want to. And it's all it runs just about everywhere. Yeah, you can run it in the IBM environment. You're more than welcome to, but you don't have to. It runs in just about any runtime environment that is available in the open source scene right now. So yeah, that's if you want more, you can always try for yourself and contact me if you need help with that. So yeah, what was happening? I was in the beginning of the year, March, April. I was asked to work from home by IBM, as all the IBMers were at that time, because of strict measures that were being taken because of all the COVID outbreaks all over the world and in the Netherlands as well. Oh yeah, I am from the Netherlands basically, but you'll see some Dutch graphs here, so you'll see that. Yeah, so I was at home. My wife happens to be a nurse, so she was already busy working at our local hospital with suspected patients at the time in full isolation. I was wondering what shall I do this year for workshops. So I thought, yeah, let's have a look at the data and perhaps can also from that have some contribution to the situation. I mean, everybody's working hard to solve this problem and to see what you can do about all the outbreaks and the epidemic worldwide, the pandemic, I should say. So I was wondering what kind of data is available, what can I do with that from my experience as a data scientist. And then also as what can AI mean nowadays? How do you approach this data? So yeah, I was really, to be honest, wondering in the beginning why nobody said, yeah, why don't you just fire up your AI system and solve this problem? Just put in the data, put in all the measures, put in the epidemic data, and see what comes out. Hardly anybody asked me, and I was to be honest, I was a bit amazed about that, because if you believe all the hype around AI these past years, something like that should be possible. But yeah, it isn't. Let's do the reality check up front, because it's not that simple. But yeah, to be honest, I was a bit amazed about that. So, but yeah, then with all my practical experience, I just started analyzing the data and finding out what can you do with this data and how can you gain insights from it. So that's what I'm going to show you in an overview, and it's about 6 months of development and research into that data. So it will be a bit high level overview of that. So yeah, you should be seeing my Git page right now, which is just there as a start, and that's where all the stuff is available. So we'll send you the link, and you can have a look at the code and all the data that is available there yourself. Yeah, and first thing what you do as you're starting to look into a new domain, and to be honest, epidemiology was a new domain for me. I had done lots of stuff. Lots of industrial and financial analyses and projects, lots of stuff in marketing, also some capacity around healthcare, but never really looked into disease data. So that was new for me as well. So then, yeah, first look at data. Where's data available? That's what you do in a case like that. So I looked around, and at the time, already in late March, early April, when I started this, the EU CDC already had a data set available, a daily data set worldwide with all the case data around COVID. Yeah, my usual approach in projects like this is start with as little data as possible. That may sound a bit strange, but then I say start with the bare facts, see what you can see in there, and if you find anything that you don't understand, you probably need more data to really explain what is going on in your original data set. So you build it up step by step by analyzing the data. That's what the approach that I also used in this case. So yeah, I had a look at what's available, and the EU CDC had an early data set available, which was daily updated, so that I could just download the daily case data every day. So that worked pretty well. So that's where I started. So this is easy because they just have a download link. There's an Excel file available there, and it was already in the first weeks pretty stable. So I just started exploring that. Yeah, what does exploring mean for a data scientist? Getting the data into an environment where you can start asking questions. That's how I always put it. So yeah, I put it into this open source analysis environment. In this case, I'm showing you it running in the IBM cloud, but you could also use it. It's basically the most used open source environment for this kind of stuff. It's Python, it's Jupyter Notebooks, if you know the terms. But that's what everybody uses when they're using open source tools. So yeah, just get your data in this environment first, and then yeah, the original data looks like this. It's just a couple of columns. So it's basically a very narrow, long data set, as I always call it. And the columns that I used were the date reported. So on what date was a number reported. The country, obviously, this is country data. Just in this case, it's Afghanistan, and the number that was available in this case, the case data. So I decided to start out with the case data, so that this is positively tested cases, and have a look at what can I find in that kind of data. So yeah, then it's a matter of reorganizing stuff. So we data scientists spend a lot of time in data wrangling, as it's sometimes called, but it's getting the data in the right shape for analysis, basically. So I created this overview where you have cases, where you have deaths, you have a row for each date, and then you have the countries in the columns. So you can start analyzing a column for a country, you can start comparing countries. So that's where I started off. Yeah, and all this is still manual work. And I mean, there's still no automated systems that you can simply point at the data set and say, let me know what's in there. I mean, this is all stuff you have to put in yourself, because you know what a country column is, and you have to make decisions about how to organize this data, basically. So there's some tools starting to appear that help you at least in what's in the columns, and can I use this data for analysis, but it's a lot of work still, and let's be honest, still 80–90% of the work of a data scientist is still getting data into the right shape for the analysis that comes afterwards, before you can apply the AI. Let's put it that way. Yeah, and then it's a matter of first starting to draw your first graphs. If you have your data in the right format, it becomes really easy to start asking questions. So here, you don't have to understand all the code, but you say, okay, I'm looking at cases for the Netherlands, cases NL, and I want a plot of that. So that's basically a lot of work before this to start using these simple statements. So if you're interested in Belgium, for example, you just put BE here, and you have the graph for Belgium. So you can start looking at the data. Then you already see why it's so hard using automated tools on this kind of data, because if you look at Belgium, you already saw that a little bit in the Netherlands, but in Belgium and lots of other countries, you see a very weird effect. If you look at the reported case data, you see, okay, I've seen this, what we call a sawtooth pattern, that it goes up and down all the time. And then you really, yeah, you have to dive in. This is one of those first questions that come up if you look at the data. How does this happen? Why do we have more cases on Tuesdays, basically? If you zoom in on this, you see that the peaks are on Tuesdays and sometimes on the Mondays. Yeah, and then you dive in and you find out that this pattern is caused by the reporting process behind it, which causes a lot of cases from the weekend to be reported on Mondays or Tuesdays. So it's just a reporting lag. So you already see from this that you have to look at a week as a whole, more or less, to see the amount of cases for a week. Because if you look at every day, then you start reacting on all kinds of weird patterns here. And that also means that if you run an automated procedure on this kind of data, it will simply predict, especially when you're at the beginning here, if you're only still at the rising stage of the epidemic, which we have again in Belgium, in the Netherlands, well, just about all over the world. The tool, the AI will simply report to you, expect high numbers on next Tuesday, and also expect them to be higher than last Tuesday. That's basically what you can get from this data if you just run an analysis on it. which tells you something. And you find out that there's a weekly reporting pattern, but it doesn't really tell you something that you can base decisions on. So maybe about the process, you can tell these process people to start delivering their daily data, not on the Tuesday, but on every day. But yeah, it's still hard to base decisions on that kind of analysis. So yeah, automated tools can help you a lot, but you always have to keep in mind that they jump on the first pattern that they see, and that's what you get out of it. And usually, to be honest, that's a pattern that you already know and that you have to correct for. So so it learns you something, but not yet about the real world. So yeah, there's lots of stuff that you can do to the data, obviously, to smooth out this pattern. So that's what I started investigating. You can look at other types of data. So here's the disease data for the Netherlands in this case. You see that the pattern there is even stronger with the weekly reporting. And you can see that it didn't rise that high yet as the new cases, but there is a very worrying trend going on here, because even the disease rate is now seriously starting to rise in the Netherlands, but also in other countries. So I haven't looked at the Belgian figures recently, but let's have a look. Yeah, there you see the same pattern. And if you look at other countries like Italy, for example, you can also see that it's not that bad yet, but it is starting to rise. And yeah, with all these very fast growth rates that you sometimes have, this can get worrying pretty quickly. So yeah, this is the first exploration, just asking questions, looking at the data, seeing what's going on. And yeah, you still, yeah, I would say you still need human intelligence to do that properly. Yeah, then I tried to reproduce a lot of the graphs that you saw in the papers, basically to see if my data was correct and if I could understand it correctly, what was going on. You see weird stuff like in China, where they suddenly on a day in February, they reported 15,000 cases, yeah, which is something you have to deal with. And if you just run an automated procedure on this, it will probably jump on this peak and say, okay, that was a really bad day. Well, you know, as an analyst, that this can't be right. I mean, you see this more or less this outbreak below, and you suddenly see this peak. So these were cases which they found in their database, and they did not have a date attached. So they had to choose when to report these cases. So they all reported them on one day. Yeah, and then when you process this data, you as an analyst have to make the decision, how do I deal with this? Do I simply leave them out? Then your totals don't add up anymore. Do I spread them over the past week, or do I spread them over the past month? That's always assumptions that you have to make, and that get put into your data, which you will probably see back when you start seriously analyzing this. But yeah, it's a lot of work to get the data in the right shape. You have to cater for all these kind of weird effects. For example, if you look at Luxembourg, you can see they even reported a negative amount of cases somewhere in September, which is just a correction. They basically said over this period before, we seem to have reported too many cases, so we're going to adjust for that by just doing a negative correction of about, what was it, 1,400 cases that we're not going to count anyway. So yeah, obviously, if you start doing trends on this kind of data, it gets difficult pretty quickly. You can also see there's missing data. There's a gap here. There's all kinds of stuff that you usually see with this. So yeah, that's a lot of the work, and that's also why you can't just take a data set from anywhere. And even this is officially reported data. You can't just take your data set and put it into an AI and expect all kinds of stuff to come out, because if you do that, this will come out, and that may not help you that much. It basically, if lots of countries do this, it will start predicting that you usually have a negative amount of cases somewhere in September, if you just start analyzing this, which is something that may be true, but it doesn't help you much. So yeah, lots of work. I reproduced most of the graphs that I found. So these are relative new cases. I looked at the doubling amount of the number of days where the amount of cases will double. So that's all stuff that you can then, if you know the right code, which is on top here, if you know the right code, you can simply reproduce from the data. So that's what I started out with. Yeah, and then after a while of messing around, I returned to my original question, which was how can I say something about the healthcare system? I mean, thinking about my wife working there, lots of people, lots of diseased, infected people coming into the hospital. What can you say about how hard is an organization hit? Then I decided to look at the number of people that were concurrently infected. So that's the amount of people that at any time can infect somebody else. So that says something about how hard is a country hit. And it also tells you something about the healthcare load, because a percentage of that, which varies, but you know the variation, a percentage of that ends up in hospital, and another percentage of that ends up in the ICU, which at that point, at least in the Netherlands, but in many countries, was the largest problem that we were facing. There were so many people in the ICU that we were almost at the maximum capacity there, and we could not admit any other patients anymore. So that was really becoming a problem. So I decided to look at the concurrent number of infected people. And if you draw that graph, that's a formula you can use. If you draw that graph for a couple of countries like here, you can see at the peak, for example, in Spain, which is the green line here, they had about 100,000 people concurrently infected. So at that point, somewhere in April, there were 100,000 people in Spain that potentially would infect somebody else. That's what we're telling here. And a part of those people were so heavily infected that they actually had to be admitted to hospital or even end up in the intensive care units. So that's the number I was looking for. But then at the time, I did not have the full curve for many countries. I mean, I was looking at this somewhere in the beginning of April. So if you look at, most of these curves here, I think only Italy was then already a little bit over the top here, but other countries were still rising. So I was trying to understand how that curve would run for most of the countries. And if a country was on the rise, if I could predict by using, well, clever analysis, let's say AI type analysis, if I could fit this curve in some way to find out where the top would be and then how high that top would be. So there was quite some study, to be honest. I even need a lot of high school mathematics for that. I had a look at epidemiological research into all kinds of outbreaks, Ebola outbreaks, flu outbreaks, and what was known at that time about COVID. And I ended up with a way of approaching this first wave. Let's put it that way. So for most of the countries, they were in that first wave. Yeah, because if you can predict that, if you can find out when the top will be and how high that would be, you can also calculate how many people will be infected at that moment. So how hard would that country be hit? So I found out this distribution, and I won't go into much detail, but actually I loaned this from my work in predictive maintenance, which may sound a little bit strange, but I saw everybody at that time using the official compartment models, the SIR model. You may have heard about it, where there's everything's based on the infection rate, which is the R number that everybody's talking about. And basically the number said, the model says there's three compartments, the S, the I, and the R. You're either susceptible, so you're still can be infected. You are in the I compartment, then you are infected. And then eventually you end up in the R compartment, which is the removed compartment, which means you either are recovered or something bad has happened, but at least you're out of the infected compartment. But then you have there's this underlying R figure, which you have to estimate then to find out how you are moving between compartments and how many people are in there. So what we did in predictive maintenance, and I did a lot of projects in predictive maintenance, we don't try to predict when a machine will fail every day. So we don't look at the probability of something to fail on a certain day. We look at the time to failure. So we look at if we put a machine on the floor and we just switch it on and let it run, after a certain amount of time, typically it will fail. And you can draw a distribution to show some machines will fail early, some machines will fail late, and you can draw a curve on that. And I used the same approach in this case. So I didn't look at the probability of getting infected on a day. I looked at the distribution of how long it would typically take for somebody to get infected. And if you look at it that way, you can without doing any assumptions about infection rates and stuff like that, you can say a lot about how this curve will run. So I ended up using this distribution. Let's not dive into the details, but just look at the shape. And this is typically the shape that you also see in an outbreak, where there's a fast rise, there's a peak, and there's a slow long tail, as we call them in statistics. So the right side of the graph is always longer than the left side of the graph. And a lot of people made mistakes there. I still remember, for example, in the US, somebody who said, yeah, this is a typical bell-shaped curve, so it's symmetrical. So we're now on the rise, we're almost at the top, and the right side will look the same. So we will end up with about 60,000 people deceased in the US, which is a lot of people. But on the other hand, there's 327 million people in the US. So yeah, we can handle that. But that was the assumption that the right side would look the same as the left side, which it doesn't. And there was another assumption that went wrong, that would be the only outbreak in the US. There obviously were more outbreaks than that. So you can easily go wrong here if you take the wrong assumptions. Yeah, then I just started testing this. Does this work? Does my assumption work? So I started fitting this to all these countries. And I ended up with results like this. So here I fitted it for the first outbreak in the Netherlands in this case. Blue is again the raw data with this effect. The orange one, which is not very visible, is the smooth version of the curve, and the green one is what I can fit to that. So you see clearly the effect of a slow rise, fast rise, and a slow leveling of the curve. So yeah, then what I had basically was a formula to describe an outbreak and start calculating stuff from that. So because yeah, even if you only had the rise part here, you could already make an estimate on how this curve would probably progress for that country. Yeah, then it was a matter of just calculating that number for all the countries. So that's what I did. Long list of countries. You have Andorra, Arab Emirates, Afghanistan, and so on until Zimbabwe on the very bottom. And I just calculated this number for all this. So I did this assumption about this is probably what the curve would look like, and can I calculate that number? And if you then plot that number, you get a relative number. If you look at the amount of people infected related to the population of the country, yeah, you can start calculating stuff. You can say, okay, this country was relatively harder hit than another country. So that gave me a measure of starting to compare countries. So here you see a list. I'm not sure if you can read the text here, but this, for example, on top is Qatar, which was relatively hard hit. I mean, there were always almost one in 100 people concurrently infected at the top of their first wave. You see a country like Andorra, but you also see weird stuff coming up here, like the Vatican, saying, how can the Vatican be hard hit? Well, there's 1,000 people there, and at the top there were seven. There were 7 people concurrently infected. So yeah, that's 7 in 1,000, and that's a relatively hard number. I see somebody call. Is everybody still seeing my screen? Because I see a remark there that somebody lost the picture. But I hope I can just go on. Oh yeah, there's already an answer here. I can see its screen. Okay, so tell me if you can't see my screen anymore. But
yeah, it should be fine. Okay.
Okay, right. Okay, so there should be a graph of countries here. So yeah, there you can see how relatively, based on my number, which is only a healthcare load number. If you really want to deep dive into this kind of analysis, you probably want to do economic measures in here as well. But this is just a healthcare load number to compare countries, which is a start in analyzing. And you can see more well-known countries in here, like, for example, Belgium is here, which is relatively hard hit. The US is here. They are hard hit, but it is a large country. There's Belarus here, there's Italy, and so on. So there's your list of countries. So yeah, the next step was trying to relate this to how did a country behave during that first wave. So I found this data set here, which is from the ACAPS organization. And that was one of the points where I thought this is a great place where you could use artificial intelligence, which they did partly. because what they do is they gather from all the news and all the websites, the official government websites. They try to gather the measures that government has taken during the crisis. So they do a lot of web scraping, a lot of text analysis to find out if a country went into lockdown, and can we tie a date to that, and what exactly happened there. So that's a very interesting data set to look at in relation to that number that we just saw. So if we look at that data, what's in there? Basically, countries again, dates and measures. So there's a category here where you can see what kind of measure was taken in the country. There's detail there. You can see exactly the date when it was taken. So my next step was then, can I relate that in any way to the severity of the outbreak in that country? So that's what I tried to do. So I created from all this data, I created this data set, which shows you for every country the type of measure. I only took the main types, which are governance socio-economic measures, like helping an organization through the crisis by giving them a loan, for example, or by paying the wages of their employees which can't come to work, stuff like that. Is there a lockdown? Are there movement restrictions, traveling inside the country, traveling between countries? Public health measures like quarantine. Did they implement social distancing? So that's the main categories of measures that countries would take. And then what I calculated from that was a number that said how early was this measure taken relative to the start of the outbreak in that country. So what you can read in this table here, after a lot of combining all this data together, is that in the Arab Emirates, the governance and socio-economic measures were taken 2 days after the outbreak really went off in there, after the cases really started rising. So they were relatively early, I would say. But then you can also see countries like Afghanistan, which decided to try to keep this whole infection out of the country. They already took this kind of measures 53 days before the outbreak really started. So that's why this is a negative number, 53 days before the outbreak started. You can see that there were no humanitarian exemptions in most of these countries, and AN between means not available. There's no data for that. And for example, lockdown, you can also see quite some differences here. So the Arab Emirates went in lockdown 14.5 days, 2 weeks after the outbreak, and Afghanistan already went into lockdown 3 weeks before anything happened in that country. So that's what you can read from this table. Yeah, and then it's a matter of trying to combine that with the other data. How hard was the country hit in the end? And you can start drawing all these kind of interesting graphs here, where you can say, for example, if you take the Netherlands here, NL, our number, I should say, is -3.4, which means -3 would mean 1 in 1,000 people. -4 would mean 1 in 10,000 people, and so on. So we are a bit below 1 in 1,000 people on the top of our first wave. And then the machine learning algorithm, you might call that an AI, but yeah, the machine learning algorithm tries to find in the data proof for that number. That's basically what it tries to do here. So it tries to explain to you as a human why is this number -3.41, and it says, okay, this number is lower than expected. Lower is always blue. That's the good side, because we were relatively early compared to other countries in governance measures. But it's higher than other countries because we were relatively late, for example, in public health measures. We only did serious quarantine measures 37 days after the outbreak started taking off. It was also higher because movement restrictions were not really implemented in the Netherlands. It was relatively high because social distancing was relatively late, only 22 days, more than 3 weeks after the outbreak. So yeah, you can look at different countries here and find out what's going on. If you look at that number for Belgium, for example, you can see more or less the same measure, the same factors. Only they had a lower. They had to start with a much worse number, even more than 1 in 1,000 concurrently infected. And yeah, they were relatively late with movement restrictions. At least they did them, but relatively late. relatively early. It's the blue side, and you see that all these measures were taken relatively late, and that's why the number compared to other countries is different than in the Netherlands. So you can look at totally different countries, like somewhere in Africa, there's a country called Togo. They tried to keep this whole first wave out of the country, and they succeeded in at least keeping that out. So their number was way over 1 in 10,000 people. And it was relatively low because they were early with public health measures, 53 days before the outbreak, and they were early with all kinds of other measures. So that's the first type of insight you can gain from this kind of data. So yeah, if you have any requests for a country, let me know in the chat. We can have a look. Otherwise, I'll help you to get this up to speed and running in your own environment, and you can start asking whatever question you want. So this is a first look at explaining the effects in data, where we already used a little bit of machine learning and an AI-like explainer system to start explaining to find out what was really going on there. So this yeah, first step. But then yeah, I was still restricted to this first wave. I was still wondering. Yeah, this is all very nice, and you can start asking questions here and comparing countries, and even show this to the government, and they can maybe have a look at how good their policy works. But yeah, it was just the first wave, and if you look at the graph for the Netherlands, but yeah, just about every country in the world, you can see clearly this first big wave here. But there's lots of stuff happening after that as well. So I really started to look in, can I make some sense of this series of outbreaks, which it clearly seems to be, if you look at the data. Yeah.
Hi, Damian. One of the participants wishes to see France. Just before you go on, can you show?
Okay. Yeah, sure. I can. We can have a look at France here in this graph here.
Yes.
We can have a look at France. Yeah, so this is France. You can see that they had a relatively, it wasn't even, they have a better number than some other countries. So it's a bit over 1 in 1,000 concurrently infected. And you see that that number was lower than on average because of social distancing. So there were social distancing, yeah, 40 days after the outbreak. That doesn't sound early, but it seems to be better than average. And that's why this number is lower than you would expect in a country to see. But then, yeah, the number was higher because of public health measures being at 44 days, governance socio-economic measures at 37 days. This is a number that really influences these two. And they were, yeah, relatively late in doing a lockdown, 23 days after the start. So that's the kind of data that you can find here. Yeah, but yeah, keep in mind, this is a relative number, so I'm just comparing countries here. So I compare France to all the other countries, and this is where they are different. And it's also not a value assessment or something. I mean, please don't interpret my words as saying that a country did something well or not. I mean, this is what they did, and this is what happened. And if this is good, here you see the effect on healthcare load. But obviously a country like Togo, as we looked at, they didn't have much healthcare load, but probably there was a bad hit on the economy, for example. So you have to look a little bit further before you really start basing conclusions on this. But at least it's an interesting way, I would say, to compare countries here. Right, so there you go. But then, yeah, I looked at outbreaks after that. So what I did is I divided, and now we're skipping about 2 months of research, basically, into how can I split this whole curve that we're looking at. We're just looking at the overall curve. Can I say something about the underlying outbreaks? So if I assume that every outbreak looks more or less the same, has this gumball-shaped curve, can I isolate these curves from the main graph, and then the other way around? If I isolate all these separate outbreaks, if I then put them together, can I explain the whole graph by all these local outbreaks or these sub outbreaks? And that yeah, it took some time to find that out, how that would work. Did some machine learning there, because basically what you do here is kind of clustering. Which you also do in marketing, for example. If you say, okay, I'm going to divide my customers into groups, and I'm going to treat each group differently. That's what we as data scientists call clustering. So I learned some techniques from there, and I found out some stuff myself. And then after a while, I was able to cluster this graph basically. So if you look at the Netherlands in this case, and you run that kind of analysis on this, and this one is also live, so we can have a look at other countries. What you see is actually what happens. I would almost say under the hood, actually. So this is the well, what starts showing up is the behavior of people in that country. At least what can show up in the numbers. So you see this low long green wave here as a start, and you see that in lots of countries. This is probably the people bringing in the disease from outside the country. So these are people returning from winter sports or flying into the country or stuff like that. Yeah, and you have to really find out yourself, what this is related to. That's something that for a machine is still hard to understand. So I didn't do any assumptions on that. I just looked at the numbers, and then afterwards I put this together to a calendar and try to look at what happens. And obviously one of the things I'm going to analyze next is from this measures database, seeing if I can find any measures that are related to the shape of outbreaks here, for multiple outbreaks in this case. But back to the graph, people bringing it in. We had this big outbreak in the southern Netherlands where there was carnival. If you look at the more local data, which I also did, you can see that this red wave happens more or less in the southern parts of the country. Then you see the larger cities following, and then we get it under control. I mean, we did a pretty strict measures in the Netherlands. Not a full lockdown, but we tried to get it under control, and we did basically. So until start of June, we really got these first outbreaks under control. But yeah, you can still see some smaller outbreaks if you look at this. It's not very visible anymore because of this huge peak that we have now here. But there are outbreaks that you can relate in time to national holidays like Easter or stuff like that, where people come together there, and you can see new outbreaks happening after that, about a week after stuff like that happening. So this might be Mother's Day, this might be Easter. There's some stuff that you can start researching if you look at the data in this detailed way. Yeah, and then so somewhere half July we almost had it under control. But yeah, then the holidays started. So people go on holiday, people return from holiday, students get back to school, schools are opened again, and now we're really into trouble again. I mean, we are really having a big, well, as everybody says, second wave. But if you look at the graph right, I call that the 13th wave in the meantime. And you can even see with the recent figures. I mean, these are today's figures. The most recent figures, we're really breaking out of the trend as well. So this is very worrying. I mean, this really shows you that we are still in the tails of a couple of large outbreaks, and we are already rising above that. So in a couple of days, probably you'll see something new being fit here, and that doesn't look very good. So this really gives you some more insight by trying to cluster the cases into separate outbreaks. So yeah, I was very worried when I looked at the new data just came in. It usually comes in somewhere between 12 and 1 on a day. So I did have a look at a couple of countries in this case. So if you look with the new data from today on Italy, unfortunately, it's already there's enough data there to really fit a new outbreak wave to that. So then you get this kind of effect. We are now here actually in Italy, where my cursor is right now. But the trend here right now, let's say if they don't act upon it, they would progress into this huge outbreak that would be happening. And then obviously they don't. I mean, already this morning there was in the news that they are already starting to take much more strict measures. Luckily, so this wave will, if they take the right measures, this wave will not happen. That's always the problem with these kind of projections, that you only can project what will happen if nothing changes. But I hope they will do the right thing and prevent this outbreak from happening. But yeah, today it looks like this, and that is really worrying. And yeah, I see that in lots of countries, to be honest. And yeah, even in the Netherlands, we're almost at a part where we can where we can fit this new outbreak to the data. Yeah, so that's a way that I found out to look at data in more detail. And yeah, this is something that is based on a lot of technology that you also see in machine learning and AI systems. And I would really like to do the exercise now to tie that to actual events that happened in the real world, which will be a bit more complex analysis. And I'm not there yet, to be honest. So that's enough work for the rest of the year, and doing workshops about that. No worries about that. So already this one is quite interesting. Yeah, and then obviously the same trick that I did with the fitting the first wave, you can run this for all countries. I mean, that's the nice thing about automating this whole stuff, that you can then just put in all countries and start running this for all the countries that you have in your data set. Yeah, and then I got a bit tired of looking at all these graphs. I mean, it can be very interesting because you see all kinds of effects and different ways of how the disease spreads to the country. So you can learn a lot from that. But then I try to figure out a way of getting this into one overview. Then yeah, the obvious candidate for that would be a map. So that's what I try to do. Because I know where these countries are. I now have a fitted curve to that, so I can put my fitted curve as data on a map. But then yeah, there's one thing. It's a map, but then it also needs to show you something about the outbreak. So I created an animated map, which is something you can do with the right tools. It's a bit of programming because you have to get the data in the right shape. So I spent about a week, I think, to getting the data in the right shape, and then it's only 5 minutes to create the map, because there's a library for that. But it's again, it's still a lot of data wrangling to get it in this format. So yeah, I'll just show you what comes out of that. So it shows the data from when it was available to 1 week after today. So I do a little bit of prediction on the end, and you can see how the stuff spreads. So now you can see it appearing in China, which was relatively not that large an outbreak. There you see Europe following, the US comes along, Russia has the first outbreak, Brazil follows. You see it moving towards Middle East, India, other South American countries. South Africa is pretty hard hit. Then you see Middle America, and you see it getting back to Europe for the second wave, basically. And then even Russia is rising again. So I guess the vaccine isn't working that great yet there. Let's see how it goes. But then it ends up in this kind of picture, where you can see what I project for 1 week after today. And yeah, you see 1 week after today, obviously we're still in big trouble. I mean, the major countries are still here. But it's an interactive map, so you can also zoom in on it to have a look at what's going on in Europe. And you see that the hotspots right now in absolute figures are France and the United Kingdom. But yeah, you can basically see it's almost all over the place. It's still yeah, not looking good. Spain is relatively getting a bit less worse, let's put it that way, than for example France and the UK. But you can see that also Eastern Europe is getting hit hard again. Israel is still in trouble. Yeah, and then yeah, obviously India. These are absolute figures, so you could also do relative figures, but then obviously in absolute figures, India is hit pretty hard. Also Pakistan there, and Indonesia, Philippines. There is still quite some trouble in the world. So yeah, so this is more or less let's put it this way, a summary of all the data that I could gather, all the analysis that I could put into it, fitting it, putting it into separate outwaves, and then plotting it onto a map to present it to people to start drawing conclusions. You can also see how it progresses around the world. You can look at more detailed data. For example, if you look at US states, you could do a local map of the US states. I did that for the Netherlands as well. So yeah, So yeah, that is what I've been up to these last 6 months. So there is, yeah, let's put it this way, there is quite some AI under the hood, what people usually would call AI, I would say. But you can also see, and that's what everybody who seriously dives into this kind of analysis finds out. There's still so much work to do to get the data into the right shape, to put your assumptions in there, like what does an outbreak look like? If you don't put in that assumption, yeah, it's just raw data, and you can't expect any machine to make sense of it in terms that you as a human would understand. So basically how it works is that you put in your assumption where you say, I think that every outbreak has this kind of shape, go find that kind of shapes, and then tell me where they are, and then you have something that you can understand as a human. So it's still a matter of putting in a lot of human intelligence to get something out of the system that you can use as a human then again. So that's basically the story of this project. But yeah, I would say in any project that you start in AI or machine learning.
Thank
Right.
you. Thank you.
That's it for now. So any questions? Yeah.
I have to, as I'm always the first, I mean, it comes directly from me. It's a super interesting talk with you. And I question myself, how can I, as a person, access what you just showed? Do I have to be or can I ask you? Or
no, yeah. It's right now. It's I mean, let's be honest. It's in development stage. So if you are a developer, you can pick up the code and run it for yourself. But you have to have a bit of developer background and the right environment to do that. So right now, I'm in the stage of getting this into an application, basically into a website, where you would have a drop down of countries, and you can simply see the graph for that country. Or you can just access the map on a web page. I do have a couple of test maps available, so I can send you the links, and you can send them around where people can just look at. But yeah, keep in mind that it's in development. I won't update those maps every day, and sometimes when I'm update, there's some weird effects there because there may still be a kind of effect in the data that I haven't found yet. But yeah, it is available a bit, at least as raw code, and it will become gradually available as an application or a website in the coming months, probably.
Yeah. Great, because that's I mean means the most. I have so many questions. That's why.
yeah.
Answer. It's the time slot is short, so yeah, there will be a web application. Please send also the information for developers, and any developer out there who has now interest, of course, write me an email. I send it to Damian or write directly to Damian. But now I give the floor to the participants because there are many questions. I think we could be 2 hours here, no problem.
Yeah, I'm used to that. So yeah, so let's do 10 minutes and yeah, I mean, if there's still lots of questions and we have enough discussion for another hour, but I'm fine with that. So we could plan that in any way, but let's keep it to the 1 hour for now.
It is, and sure. I re-invite you.
Yeah.
So Hugo Rasodo, when you say the outbreak started, you mean in a specific country, right? What do you define as a start of outbreak or base value?
Yeah, in this analysis, I used country data. So when I say start, I mean the start in the country. Yeah, what I usually do, and what I see a lot in published papers as well, I take the date where the amount of new reported cases rises above 1 in a million for that country. So in the Netherlands, we have 70 million people. So the first day where it starts rising above 17, I say that is more or less the start of the outbreak. So that's how I do the start and the end as well. Yeah.
Good. And then comes Sophia Rolle. She was like typing these questions already during a presentation, but basically when you showed the wave through the, are these absolute numbers on the map? I mean, it seems they are.
Yes, they are. Yeah, so it's a choice. I mean, I could do a map for relative numbers as well, just as easy. In this case, especially when you look at the Europe map in this case, if you do relative numbers, yeah, you get another picture which you can use for other for comparing countries on a relative level. But then you would see weird effects like the Vatican popping up and Andorra popping up, and there would be this huge red dot there. So yeah, that if you want to see it that way, you can do it relative as well. But it's a choice I made. Yeah.
And here's Natalie from Saint-Pierre from Canada. Hi, Natalie, one of my big followers from Canada, who will also be a speaker. What are the resources needed for you, Damian, to speed up the development of this, what you just talked?
Yeah, well, right now it is basically just web development. So I'm already talking to a colleague who has a lot of experience in building web applications, and that's basically what's going to happen. And then when I talked to him last week, he said, yeah, it's probably not even that complex. I mean, this map is already ready to put on a website. I mean, you can see here on the bottom, I just exported as an HTML file. So yeah, you can simply, if you have a web server, you can put on this file and you have an interactive map available. So that's pretty easy. And so the only thing that would be, yeah, a little bit of implementation, but not even that much, is something like a drop down for countries or regions where you then get to see the current fitted waves for that country. So it's not even that. So it might even be very quickly that I get this up and running. I just haven't started it yet because I was still taking out the last problems in analyzing this data. And that's basically one of the biggest things that I ran into, is that lots of countries are slow in reporting cases. And again, that's not a value assessment. That's just what happens. So I saw at a certain point in time, I saw all the graphs going down at the end. And that meant that the cases for those last days were just not reported yet. So I saw it went down all the time. So I always had a down slope at the end. So then I had to correct for that, obviously, because those cases were coming in the days after. So there was no downslope really, but you could only see the rise after a couple of days. That kind of stuff. So I'm still taking out a couple of those kinks out of the analysis, and then it should be good to go, I guess. Yeah.
Here comes the question. It's like, as you showed us the different countries, it was basically this relation between this S, I, and R. And you showed us the different countries, and then you showed us the map. What I learned with common sense is, as earlier the countries would basically apply these measurements, like health measurements, like lockdown, like anything, the Gumbel curve would somehow slowly go down, right?
Yeah, it would flatten. That's flattening the curve, basically. Yeah, exactly. Yeah.
So the common sense tells me, as earlier, when I would be now the president of my country, as soon as I see the wave rising, I would put all these measurements, like in New Zealand did it, basically put all the measurements up and basically stop anything happening.
Yeah, that's something. I mean, for New Zealand, that was easier to do than other countries because they are an island. So it's pretty. Yeah, let's say it's not that hard to control what goes in and out of the country, because you could see that movement restrictions are a pretty big factor in this. So movement restrictions were not that hard for New Zealand. I mean, if you stop flying and you check every boat that comes into the country, you're basically there. But then, yeah, as I said, that this was only showing you how hard the healthcare system was hit. I didn't yet look at economic impact of these measures. So yeah, that is something you also have to take into account. Obviously, I mean, if you save the people, but there's no economy left, then or the other way around, that's not one of the places where you want to be. So there's that. And if you dive a little bit deeper into the details, you see that countries who went in a lockdown very early, related to the outbreak, were hit pretty hard anyway. And this is because simply people were put into a lockdown and nothing happened. So for a month, everybody was in lockdown and nothing happened in the country. So people started, and there was still officially a lockdown, but people started ignoring the lockdown. So in the end, you're looking at human behavior. You're not looking at the measures, you're looking at how people behave in reaction to the measures. So it's then it's not always a good idea to take very early measures, because people, yeah, when eventually it starts going wrong, people are already ignoring those measures. So then it doesn't help. So there's a bit more to it than just early measures. Yeah.
But that's, I mean, now we are ending the session today, which I could go on forever, but
yeah, sure. Yeah.
Problem. We have to balance and we have to use common sense. It's good to look as a data scientist. For me, have a question, find answers, but of course the common sense is.
For me, your sound is gone, Carmen. I'm not sure if that's for everybody, but I couldn't hear what you just said.
Do you hear me?
Yeah, there you are. Yeah, you're back. Yeah.
Okay, super. Yeah. So this is anyway the end of this session. I'm trying it now with the other computer once more.
Can't hear you, sorry. Yeah.
Okay, we are ending now today the session.
There's lots of feedback, Carmen. So yeah.
Say goodbye to everybody.
Bye, everybody, and let me know if you have any questions. See you.
Bye bye.
Bye.